Okay, so this question is a bit harder than the other ones, okay? So he goes, let A, B, C, D be different whole numbers. Whole numbers. And that means that, hey, they could be zero or positive whole numbers. So include zero anyways, okay? And it goes, hey, what is the number of triple pairs such that the equation is true? A plus B plus C is less than or equal to 18. So this one here, number one, they could be whole numbers. That means zeros are allowed. So the sum is 18, okay? That means you have 18 rocks, okay? Number two, since it's less than or equal, that means your last stick is not fixed. So that means the last stick is not fixed. So what that means is, since there are three variables, you're free to move around all three variables. So that means you have three sticks. Okay, so altogether, then you'll have like 18 plus 3, so 21. Choose 3. Okay, now the only reason why this question is hard is because of this single word here that you see on the beginning, and it's the word different. Okay, let me just highlight this. A, B, C be different whole numbers. That means that A, B, and C are actually not allowed to be the same. Okay, so what that means is now you got to subtract all the numbers where you have repetitions, that where numbers are the same. So third step is I'm going to count all the doubles and all the triples that you can actually have. Okay, so let's say you have like 0, 0 for the two numbers. Like let's take a 0 and 0. Your third number could be anything from 0 to 18. Okay, that means you have 19 choices. Okay, you could have 1, 1. That means this third number could be 0 to 16. That means you have 17 choices. Okay, you can have 2 and 2. Okay, and then this third number could be 0 to 14. That means you have 15 choices. So let me write this all down. 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, and 9, 9. So again, in case you're wondering what we're doing is we're trying to get rid of count how many bad ones there are. These are the ones where numbers are actually repeated, okay? So you have a 3 and 3. Again, this last number could be anything from 0 to 12. 4 and 4, it could be 0 to 10. That gives you 18 altogether. 5 and 5 could be 0 to 8. 6, 6, it could be 0 all the way to 6. 7, 7, it could be 0 all the way to 4. And then 8, 8 could be 0 all the way to 2. And then 9, 9, it could be only be 0. Okay? I'm going to use a red pen, and we're going to count how many do you have all together now, okay? So, whoops, this will be red pen. Okay, so over here you have 19, 15, 17. From 0 to 12, you have 13, okay? This will be 11. This will be 9. This will be 8. This will be 7. This will be, no, sorry, no, that's all. It'll be 9. This will be 7, 5, 3, and 1. Okay? So altogether, let's add all this up. Now, a quick way to add just a list of odd numbers are, they're all increasing by 2. So 1, 3, 5, 7, 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 odd numbers. That means that altogether the sum will be 10 squared, which is 100. Okay? Now, the problem is, when you have a double versus a triple, you have a different amount of like ones that are repeating. For example, if you have like 0, 0, like 1, this could also be like 0, 1, 0, and 1, 0, 0. So basically every 3 repeats itself. Okay? But instead, if you have a triple like 0, 0, 0, there's only one way. Okay? So what we'll do next is, okay, step number 4, let's count the triples. Okay, how many triples can you have that add up to a value that's less than or equal to 18? So you can have 0, 0, 0, 1, 1, 1, 2, 2, 2, 3, 3, 3, 4, 4, 4, 5, 5, 5, all the way 6, 6, 6. So altogether you have 7 ways. 1, 2, 3, 4, 5, 6, 7. 7 ways where the numbers are triples. Okay, so that means that, hey, how many doubles do you have altogether? So number 5, where you have only doubles. So doubles will be the number of, in total that you have, the total minus the triples. Okay? What I mean by totals are all the bad totals. Okay? Bad totals. Okay? Bad totals. So you have 100 minus 7, that gives you 93. So you have 93 sets there that are doubles only. Okay? Now for every set of doubles, there are actually 3 other ways. So number 6 is all number of bad sets. Number of sets with repeats. So this will be 93 times 3, because for every set of doubles there's 3 ways, plus 7 triples. So altogether, 93 times 3 plus the 7 gives you 286 sets with repeats, meaning like you have a number that repeats itself. So altogether, your answer, which is the sets of A, B, C, where A and B and C are not the same, will be 21 choose 3 minus 286. Okay? So 21 choose 3 will be 21 times 20 times 19 divided by 6. And then minus 286, that gives me 1,044 altogether. Okay? I hope this one makes sense, and I'll be creating a PowerPoint just for this one so you can follow through.